Hey my dear data friends, it's Nicola from Data Mozart. In this video I will show you how to fit 200 million rows table in less than 1 gigabyte. Not less than 1 gigabyte, but in 20 megabytes. I know, you think I'm nuts, and I hear you talking, Nicola, are you crazy? 200 million rows can't be accommodated in 20 megabytes. There is no way. Well, technically you are right, but practically I'll show you how you can make enormous memory savings while at the same time preserving performance with some neat data modeling techniques. Stay tuned! When you're dealing with technology, sometimes you need to accept the fact that there are certain limits, especially when it comes to resources available. And sometimes, maybe more often than not, business requests are such that it's hard or almost impossible to implement within the current setup. I faced a quite challenging task recently to migrate SQL Server Analysis Services multi-dimensional solution to Power BI. The issue was that the client has Pro license, which means 1 gigabyte model size limit, and there were approximately 200 million rows in the fact table and constantly growing. I knew at first sight that there is no way to accommodate 200 million rows in under 1 gigabyte, no matter how narrow and optimized this table is. Despite applying all the best practices for data model size optimization, such as reducing the cardinality of the columns, here this simply wouldn't work and it looked like it's impossible to fit. So when I start thinking about the possible solutions, the first and most obvious idea was to use Power BI as a simple visualization tool and just do a live connection to a SQL Server Analysis Services cube. However, this solution comes with the serious limitations. The most remarkable one, you can't enrich your semantic model by writing report level measures. And that was one of the key requests for this client. Therefore, live connection was immediately discarded. The second obvious solution was to use direct query mode for getting the data into Power BI. Instead of Analysis Services Cube, Power BI will directly target fact and dimension tables from the data warehouse. Despite all its limitations, direct query looked like a completely legitimate and the only possible solution in the end. And this was the best I can thought of. Until I found this Phil Seamark's blog post about filtered aggregations that opened a whole new perspective to me. This complete series on creative aggregations is awesome and I strongly recommend to read all parts of this series, but this specific concept was enlightenment to me. So let me try to briefly explain the idea of filtered aggregations, or let's call it filtered aggregations in a nutshell. I won't go into details about the concept, as Phil explained it much better than I ever would. Essentially, the idea is to separate hot and cold data, and then leverage the composite model feature in Power BI, importing the hot data in Power BI while cold data will stay in the data warehouse and be targeted through direct query. On top of that, applying aggregations within the Power BI data model will bring even more benefit, as you will see later. Now, I hope you're familiar with the terms hot and cold data. For those of you who are not, hot data is the most recent one, where word recent has typical it depends meaning. It can be data from last X minutes, hours, days, months, years, and so on, depending on your specific use case. In my case, after talking to report consumers, we've concluded that the most of the analysis focuses on the data from previous 3 months. Therefore, the idea is to extract hot data dynamically as the data from 3 months prior to today's date and store that data in the Power BI tabular model. Report consumers will benefit from fast queries as the data would be optimally compressed and kept in memory. On the other hand, when older data is needed for analysis, cold data, Power BI will go directly to a data source and pull the data from there at the query time. Finding the tipping point which means the point in time to separate hot and cold data, is of key importance here. If you opt to use a shorter period for hot data, you will benefit from having a smaller data model size, which means that fewer data will be imported in Power BI, but you will have to live with more frequent direct queries. So it's a kind of trade-off. Basically, you're choosing between reducing the data model size and query reduction to improve the report performance. But enough theory, let's jump into Power BI Desktop and I will show you all the steps to fit your 200 million rows fact table in less than 1 gigabyte. Okay, here you can see that I have 200 million records in my Power BI Desktop file and all the data is imported. If I go to external tools and open DAX Studio to see the size of this data model, so I only have this fact table. No dimension tables, only fact table. And if I go to Advanced tab and click on View Metrics, you can see that my table has cardinality of 200 millions, of course, and in Summary tab you will see that total size of my data model is 2.36 gigabytes. So that's our starting point here. This is second PBIX file, connecting to exactly the same data source. But this time I've splitted my giant fact table in two separate tables. Let me show you here. And I called them hot and cold. Let me show you the logic behind the data for both of these tables. So I will go to SQL Server Management Studio, and this first table, the hot table, contains data from the previous 3 months, dynamically calculated based on the getDate tsql function that returns current timestamp. On the other hand, cold data contains records older than 3 months. One important thing to keep in mind here, you need to ensure that there is no overlapping between these two, between hot and cold data, but also no gaps in between, so you get a correct result in the end. Let's turn this off and go back to Power BI Desktop. So you see that I've created both of the tables in direct query storage mode. You can notice that because of those blue lines on the top that marks direct query storage mode. So then I will first build an aggregated table over my hot data, and this table will use import mode. On the other hand, the cold table contains remaining 190 something million rows and it will use direct query mode. On top of it, I will build a few aggregated tables to cover different dimension attributes, such as the date in my example, as I don't have any other dimension tables here. And I will also use import mode for this aggregated table, so Power BI will need to switch to direct query and target the original data source only for those queries that are not satisfied with import mode tables. Okay, let's now start implementing the filtered aggregation solution. So I will go to transform data to open my Power Query editor, and I will just duplicate my hot table. So I will click on duplicate and I will rename it and call it fact 200 million hot egg, as this will be aggregated table. I will hit close and apply, wait for a few seconds. I will not go into detail about aggregations themselves, as there are really awesome resources on the web such as Shabnam Watson blog, where you can learn more in detail about this very powerful feature in Power BI. So the next step is to create an aggregated table over this new one. So I will right click on this table and select Manage Aggregations, and I want to do a sum of amount from my hot table, and I want to group by date UTC. Okay, I will apply this and let's wait for a few seconds. And the final thing is to switch to import mode, to switch this table to an import mode, so it's gonna be loaded into a Power BI memory. If I go here to advanced and storage mode, I will change this to import mode. So I'm being warned that once I go this way from direct query to import mode, I can't revert it back to direct query. So basically keep in mind that you can switch from direct query to import mode, but it's not possible vice versa. So I will confirm this and let's click OK and wait for a few seconds for Power BI to load this data into memory. That's it, we are ready. So let's build a relationship between our date dimension and our newly created aggregated table. Now the performance of this report would depend on many things. If the user tries to interact with the report and wants data older than 3 months, Power BI will go and search for that data through the 190 plus million rows stored in the SQL Server database, having to cope with the network latency, concurrent requests and things like that. And let's say that I want to analyze total amount, which is the simple sum over amount column, and in order to retrieve the correct figure I need to sum values from both hot and cold tables, and I will go and write following DAX measure. Let's first go and duplicate this page. I don't need those visuals here, and let's create a new measure in our hot table. And let me call it total amount, not mount, that's football player from England, hot and cold, and let's create two variables, v amount hot, which equals sum over amount from our hot table, and the other one will be amount cold, which is sum over amount from our cold table. And finally I want to return simple addition of amount hot plus amount cold. Okay, and let's pull some simple visual here, and let's pull our measure here, total amount value, and let's go and grab our year on axis. So we need to wait for a few seconds to get our data displayed in the report. So you see all the data broken down by year. Now you would assume that if we want to see only the data from the previous 3 months, Power BI will go only to aggregated table and quickly pull the data and render the visual for us. Beep! Wrong! Let me show you. I will first turn on Performance Analyzer and let's select here last 3 months. So I will go and select, for example, from 1st of June 2021. Okay, and I will start recording. And you see that it took around 2.2 seconds to execute this query. But you see that the biggest part of this query went on direct query here. So why on earth Power BI needed to apply direct query at first place when we have our nice little aggregated table for this portion of the data? Well, Power BI is smart. In fact, it is very smart. It was smart enough to internally translate our sum over amount column and hit the aggregation table instead of visiting its direct query twin. However, there are certain situations when it can't resolve everything on its own. In this scenario, Power BI went down and pulled all the data, even from the cold direct query table, and then applied date filters. That means we need to instruct Power BI to evaluate date filters before the data retrieval. And again, thanks to Phil Simark for the improved version of DAX measure. So let me clear this and stop for a second, and let's create a brand new measure. And the first step will be to set the tipping point in time in DAX. We can do this using exactly the same logic as in SQL when we were splitting our giant fact table into hot and cold one. So I will create a new measure that I will call timeline, and let's define our variable max date. We will use calculate function to manipulate the filter context, and I want to retrieve maximum value from date UTC from our aggregated table, and I want to remove all the filters from this column, and I want to return, watch out now, so I will use exactly the same end of month function, and I want to convert to date year from my variable value. Then I want to return month of my variable -3 because we want to go 3 months in the past, and I want to return day number 1 for this period. That should work. And this measure will return the cutoff date between the hot and cold data. And then we will use this result in the improved version of our total amount hot and cold measure. So let's go back here. For this portion here, amount hot, this part stays exactly the same. We need to switch amount cold measure definition. So if I will use if logic here. So I would say if minimum value of my date from dim date table is lower than the value of my measure, I want to return sum of amount from the cold table. Remaining part stays the same, and I will confirm this. So here we are in every scenario returning sum over amount column from the hot table, as it will always hit the aggregated table in import mode. Then we are adding some logic to cold data, checking whether the starting date in the date slicer is before our tipping point. If yes, then we will need to wait for the direct query. But if not, well, let me show you. So I will again start recording, and let's go and select, for example, 6th of June. And you see that this time our data is being returned in half of a second, no direct query this time. That's awesome. So DAX query just took 52 milliseconds. And if I go and check the query in DAX Studio, let's do this. I will copy this query and I will open DAX Studio. Turn on server timings. Let's expand this window a little bit. And I will paste my query here and run this query in DAX Studio. So if we go to server timings, you see this match found message here within the query, and you can see that our aggregated table was matched and our query was mapped to aggregated table. That's fine, as it means that most frequently running queries which target data from the previous 3 months will be satisfied using the import mode aggregated table. As the next optimization step, I want to build an aggregated tables over cold data. That could potentially satisfy the most frequently ran users queries which need to pull the data before the tipping point, so data older than 3 months. That will slightly increase the data model size, but it will significantly increase the report performance. So only in some specific use cases, when a user needs to see some really low level of grain within the cold data, Power BI will fire the query directly to an underlying database. So let's go back to Power BI desktop and create one aggregated table over cold data based on our dimension table, which is date dimension. Of course, in real life, where you have multiple dimension tables, you can build multiple aggregated tables based on your dimensions. So I will go to transform data and I want to build a new query targeting my SQL Server database. So I need to provide server name, and this time I want to do import, and I will write a query to create aggregated tables. So I want to retrieve date UTC and I want to return sum of amount as amount from my fact 200 million table and grouping by date UTC. So that will be my aggregated table. Let's wait for a few seconds. And here you go. Let's rename it and call it date UTC aggregated. I'll hit close and apply, and again wait for a few seconds for this table to be loaded into my Power BI data model. Few more things need to be set here in order for this to work. First, I've built a relationship between my newly created aggregated table and my dimension table, and then I click on manage aggregations and set aggregations to sum over amount from my called table and grouping by date UTC from my original called table. Fine, so also one important thing, I set precedence property to 10, and by setting the precedence property you can instruct Power BI which aggregated tables to use first. The higher the precedence value, the higher priority gets respective table. So let's go back to our report and check performance of our measure once we include the data from before the tipping point, so data older than 3 months. So I will go here and select, for example, 2020, and I'll select March 2020, so it's half a year and a half, and let's say 1st of March, and you see no direct query, only DAX query that took around 100 milliseconds, and in total this visual took less than half second to render. If I go and play around, you will see that every time the queries will be served from our imported tables. If I copy query and open DAX Studio again, let's turn on server timings, and I will paste this query and execute it. Go to server timings, and you can see that for the called data our aggregated table was hitted, and for our hot data also we hit the aggregated table. So both parts of our measure were served from import storage mode. That's awesome. As you saw, I've expanded the date range to the previous 18 months and we got our results back in a few hundred milliseconds, while the DAX query took only 100 milliseconds. Before we draw a conclusion, let's save our report and take a look. So I will go and save this report as this one. So if we go now to DAX Studio, let's check the metrics behind our final version of the report. And if we go to advanced view metrics, let's wait for a few seconds. So here are the numbers behind our data model. You see the cardinality of our tables, and if we go to summary, you see that total size of our data model now is 83 megabytes. So if you recall, we started with 2.4 gigabytes and now we are at 83 megabytes, and that's incredible. As you witnessed, we made it. The original request was to move a data model from SQL Server Analysis Cube to Power BI Pro workspace without losing any of 200 million rows from the fact table. As I said, we started at almost 2.4 gigabytes and finished at 83 megabytes while preserving original data granularity and without impacting the report performance for 99% of use cases. Extraordinary tasks require extraordinary solutions, and if you ask me, thanks to Phil Simark's brilliant idea for filtered aggregations, we have a solution to accommodate extremely large data even into pro limits. Essentially what we've just done is that we've managed to fit 200 million rows in 83 megabytes. That's all, folks. If you enjoyed this video, please click on that like button down below. Even better, you can subscribe to Data Mozart channel and enjoy more cool Power BI and data videos.